Hi, I'm Mike with House on the Mend, and in episode 7 of our ongoing series where we are building out this Ram Promaster 2500 high roof, we are going to be installing the Renogy 3000 watt inverter into this cage I built out of 80/20 aluminum. I am going to show you exactly how to wire it, what's behind this panel right here, all the various connections to be made. And as you saw in the thumbnail, I'm going to show you how to link it to the app as well as program it for the specific batteries you've chosen. So let's get started. House on the Mend. So right next to the seating here, which we did in a previous episode, I have built this cage here, this rack. And it is going to house, in the very back, a 3000 watt Renogy inverter, and then we're going to put a pull-out drawer with the space in front of it. Right here is going to be the refrigerator. It works on DC or AC, microwave, and eventually up here an air conditioner for this back area. We're focusing today on the Renogy inverter. It's going to go right in the very back here. It's so heavy that I think I'm going to take this rack and scoot it out and lay it down so that I can set the inverter into place and bolt it down. I think it would be too difficult for me to try to push it up into place and then also get my hand in there to put bolts and things. But first, I want to show you what's inside of it and how we're going to hook everything up. Now, you've probably seen this front face in the pictures with all the wire inlet nuts, but have you ever seen inside to see where all that's going? I hadn't, and I couldn't wait to take this cover plate off and get a look inside so I could start making a plan for how I'm going to install everything. All right, first of all, you'll see way down there, right here, and the red one down here, those are your DC power coming in from our bus bars. And for that, I'm going to use the same 2-aught gauge wire that I've been using to connect all the batteries together, the ground, all the big stuff. And you can go to, say, Lowe's or Home Depot, and you can buy stranded wire like this, which is what you need, stranded wire. The problem with this stranded wire is it's really thick pieces, and it is really unflexible. It is a misery to work with. Better is to get welding cable. So this is what the guys use when they're doing welding, and it's much more flexible. This particular brand I've bought a couple times. It's Windy Nation PowerFlex welding and battery cable. This is so wonderful to work with. So just like the rest of the battery setup video, we're going to be using this same wire. I'll leave a link to the stuff that I've been buying off of Amazon. It comes with these nice lugs. These are 3/8 though, so that's good for the bus bar and anything really big like a battery connection. But down here, that's going to be really loose. See that? So what I did instead is I bought the same size wire lug, of course, but these are 5/16 holes. And when I crimp those on, you can see that's going to be much better. And it might not matter if it was stationary, but since we're going to be in a moving vehicle that's constantly vibrating, I really don't want that to move and pop off that little tiny nut down there. So that's the setup we're going to use. If you refer back to the video where we did the initial battery setup, I made one of these cables, and you can see how I did that. So that's what those two lugs are at the bottom. Now this guy right here, that it's marked BTS, this little green guy that is removable, reminds me of the gate opener video where it had a bunch of these little removable plugs that you can put the wiring into. That one there is for this included battery temperature sensor. And you would just put the wire in, then run that to one of your batteries. Now the directions on this Renogy specifically say that this is not needed for lithium batteries, and that's what we're using in my case, so I'm not going to be installing that. Now, if you look right over here, there are two Ethernet looking ports with the typical Ethernet plug. So you're thinking to yourself, well, that's got to be for the remote on-off switch, but which one is it? Do I put it in the jack that says RJ11 or the jack that says RJ45? Well, so I looked on the manual here, so you won't have to, and it says RJ11 port for connecting wired remote control. Boom, that's us. Well, what's the other one for? The RJ45 port is for future development. Ooh, stay tuned, huh? So now we know that this is going to go through this port here and plug into the RJ11 port, and then we're free to put the on-off switch anywhere we want in the cabin, so we're not having to get all the way down underneath on our hands and knees just to turn the thing on with this power switch down here. All right, now to this bank of connectors right here. There are 3 and 3. These 3 are the output. So we're getting our input from the battery here, and the output is going to go to our breaker panel. Now these 3 right here are marked input, so that is going to be for our shore power. Now I've seen some other diagrams where they're using 12 gauge wire here. I decided to go with 10 gauge wire, and you can buy it already pre-insulated on Amazon, but it was really expensive. It was like $4 a foot or $4.40, something like that a foot. So I just went to Lowe's and I bought the 3 colors I'm going to need in stranded 10 gauge wire, and these are only 94 cents a foot. So basically $3 a foot as opposed to $4.40 a foot. And if you're getting into long distances, of course, that can save you quite a bit of money. So I'm just going to take these 3 ends, 1, 2, 3, I'll put them in my drill and I'll just kind of wind them up together, and then I'll cover them with the black plastic conduit, and that's going to be very little labor for the cost savings. And I am going to connect each one of these to a ferrule. And if you haven't seen a video on using ferrules, I will link one up at the top. It's a great video, but basically you strip it back, you slide the wire in so that it comes right up to here, and then there's a crimp tool that will put a square crimp. It'll change this round to a square crimp. And it is really nice because when you screw down these holders, it doesn't just flatten out and fan out and crush this individual stranded wire. It all becomes one solid inside of this ferrule. So I'm going to do that for each one of these lines. So for the 3 wires that are coming to the shore power input connection, I found this guy here that I'm going to use, and this is rated for like 20 or 30 amps. I think it says on here, yeah, 30 amps. So some of the other connectors that were similar to this for mounting to the outside of the van, they could only accept up to 12 gauge thickness of wire. So since I wanted to use 10 gauge, I bought this guy. I do like the fact that it's got a nice weatherproof seal here, and that it can accept 10 gauge wire, and then this nice plastic cover will go over it, and I can take these 3 wires, send them up here, crimp them down so they're not getting any pull on them. So this is going to work out really good for maybe days where I want to make sure that the batteries are all topped off, or I'm running the AC or the heater ahead of time and want to get it cooled down or heated up before we head off on a trip. It's going to be nice to have shore power. That wasn't so bad. I slid it out, rotated it 90 degrees, and then laid it down on its back. Now we can get right down in here and start focusing in on this spot. I have a piece of 80/20 that's cut, that's going to go right across here, so we can bolt in on 2 spots of this rail, and then the other 2 spots on this rail to get it all nice and secure. Here's the upper rail for the inverter, and I wanted to talk about some of the components you can use for installing this rail. There's a couple different type of corner brackets. There's this one that is totally concealed, really nice, and then there's this one that goes up, connects to the piece going this way, and it's got like a big 90-degree looking triangle kind of shape to it. It's much thicker, and it's all on the exterior. These are much more expensive than these, so where possible, I've been using these little aluminum cast ones rather than these hidden ones. You'd be shocked at how many of these pieces you need for building these 80/20 cages. It's unbelievable. So you're really going to want to cut cost on all these little things if you can. So there's 2 types of methods for once you put something like this, or we put the inverter down, how we fasten it to this extruded aluminum here. The first type is a slide in. So if you can plan ahead and you can slide these in, those are less expensive than these little guys that have a nice ball bearing here, and these are what they call roll in. And they usually go in kind of easy, but I have kept in my little kit here a little piece of aluminum rod that I use to click them right into place like that. And rather than trying to get in there with your pinky and fumble around, that works great. So these slide-in ones, as you can imagine, are much less expensive than the roll-in ones. But you're going to need plenty of each, because sometimes, like in this case, we built the cage, measured everything, all the appliances for it, set it into place, and then we're starting to add on all the little things that you really just couldn't do until you make sure the cage is gonna work. So you're gonna need a mix of both of these, and if you screw up and find out as you're going along building this little erector set that you forgot a spot somewhere, it's really nice to have these roll-in ones, so get a mix of both. Now, instead of buying all my fasteners online, which is much more expensive, I've just been going to Home Depot or Lowe's and buying these 3/4 inch bolts. That is as short as you can get them in this size. That is the proper threading for these guys. So I have found that even 3/4 inch is too long. So what I've been doing, since washers are not very expensive, is I've been using 2 washers whenever I use these thick aluminum guys, and when I slide that on there, I can tighten it down with just the 2 washers. In this case, the Renogy body is much thinner than this cast aluminum, so I did a test fit, and when we secure it to the 80/20, it's actually going to take 4 of these washers. All right, this kit has been very handy for me. I can walk around, I can set it on the bench when I'm actually building a cage, or I can come in here like we're doing now and getting this piece put into place. Here's the bottom, heading towards the top. Got my rail with these guys loosely fitted in place. The reason I fit them loosely is because these little corner brackets have a nice lip on them that fits into this slot and holds it really secure. They're really cool. So let's start by popping in our little roll nuts here, and these are slotted the perfect width of the slot. So once they fit in there just right, it makes it so easy. Another little handy part of this rod here is you can slide stuff right into the right spot, or close. All right. Now, I measured, and we're pretty much from the center of this slot to the center of this slot to fit onto that Renogy inverter is going to be 10.5 inches. Might be closer to 10 3/8 or so, but let's get it right around there and we should be good. Okay, got the inverter in place, and I've got these two bolts here still loosely fastened so that at the end we can tighten it all down. So it's critical to get these little openings lined up really well so you can start threading these bolts. Now I'm going to use medium Loctite, that's the blue. If you don't have Loctite, you can also use nail polish. Just make sure you use a color that the ladies in your house don't necessarily care about. All right. Just a drop will do. You got to put Loctite or nail polish on everything because there's so much vibration in a vehicle. It'll all come loose and then you're chasing it forever, right? And this one's looking pretty good. Maybe just straighten it a touch. Yeah, I messed it up. There, like that. And in we go. I have this awesome little battery powered 3/8 ratchet. This one's made by Chemo. I also have a Husky one that is fine, but this one's got interchangeable batteries and there's just something about it I really like. Not sponsored, just it was actually given to me by a customer who didn't want it anymore when they moved. Yeah, good, there's that. Good. All right, and since I've put Loctite on them, I want to remind myself that that's done by just putting a little mark with my Sharpie. That way when I go back and inspect all my work, if I see a bolt without a Sharpie mark on it, I know I haven't put any Loctite on it. That medium Loctite has a pretty good working time. It's like a gel. All right, I got all our various cables made. Got little ferrules on these to stick into there, so let's get started. All right, these two bolts down here that hold the positive and negative, they are 10 millimeters, so I'm using this guy with an extension on here. Let's do our negative first with that 3/16 on there. I'm going to use again Loctite on these so they don't vibrate loose. That could be really bad. Good. Same thing with our positive. Next, let's work over here on our input. So that is the one going to shore power. That's going to be this one right here. So I went ahead and took off the cap and the little rubber grommet that squeezes down to hold everything in place because it made it easier to fish these through. There, how about that? Okay. Ground. Then the next one is load. So that is our black. And this one over here is our neutral. So that's our white. Real thin flathead screwdriver to get in on that guy. Do the same thing with this guy. Alright, tighten that one down. Finally, let's put in our data cable there for the remote. And that one goes in RJ11. Boom. There's a little lip on that that corresponds with this spot in here. Got my handy little DeWalt gyroscopic screwdriver here, so you just press the button and then it senses your motion and starts the drill. Okay, I'll finish these two up and then put Loctite on these two and we'll be ready to stand this up and start getting it into place for the shore power connection. Alright, so right over from the window we installed on the driver's side, down below this ridge here in a nice spot for the shore power is where I selected, and that also happens to be right in where the inverter is going to go. So I got my hole saw, and let's see how this little Porter cable drill does. There we go. It got it eventually. All right, we're committed now. Just need to clean that up and get it ready for the marine adhesive. I really want to give the screws for this shore power plug something to bite into besides just the sheet metal of the van. So I have these 3/4 inch PVC boards. They cut and mill just like wood, but they don't warp or rot or anything because it's the same kind of PVC pipe that you use for irrigation systems like sprinklers. I got this 2 3/4 inch hole saw bit here that's just about wide enough for this back cover plate that clamps the wires down. It's a little bit of a tight fit, so I'm gonna go get the drum sander, slip this on the drum and just kind of widen it open enough so it's a slip fit. That'll make it easier during installation. And then when we use the same bit to cut through the van, I will use a round file and just kind of open up the hole ever so slightly so this guy fits through just as easy. Yeah, much better. All right, let's lift it up, turn it, fish some wires through, and get it close to the right spot so we can get that shore power connection. Glad this is still the subfloor. Ease up on the roof area here so I'm not tearing down my insulation. Nice. I went ahead and turned off the solar power and the battery power, so there's no chance of this shorting out on something right now. Back in here. Just wind those up for now until we're ready to lead them back here and connect them. Now before I feed these cables through the outside of the van, I'm going to slip on this little piece of PVC board that we use for the screws to back into. All right, now it's time to head out and hook up our shore power receptacle. Well, the sun ducked below the clouds. We did have a nice shady spot here for filming. Nonetheless, let's continue on. So I took this round file and I filed out the circle so that this white portion of our shore power plug fits in there, snug but loose enough that I'll be able to make some adjustments. And then I cleaned everything off with a rag wet with acetone so that we're going to get good adhesion. Also on the inside here, because the next thing we want to do is we want to paint that raw metal, just so that if any moisture gets in there, we're not getting rust. I like to just take a Q-tip because I already have this can of regular paint, and I just go around and I get all that raw metal covered with some fresh paint. All right, I got a bunch of pre-buddy tabbed tape set up. So since I'm going to be using marine adhesive here, I want to first slip fit this guy right into place, get the tape set up, and then pre-drill the 4 holes that are going to be used to fasten it through the metal and into the little PVC piece that we made. So I'm going to slide that right into place. Now, I can't just use a level because the van isn't level. It actually slopes a little bit like this to get ready for a heavier load in the back. So what I'm going to do instead is line it up with this line as best I can. Then I got this piece set up here to hold it. while I set up some other pieces of tape. And then once I get the perimeter of tape set up, we'll open this flap up and start pre-drilling for our screw holes. Now I'm going to pre-drill those holes. Now for this next part, it's going to be pretty essential to have some help on the inside to hold that piece of PVC backer right where I want it. So I'm going to put this Loctite marine adhesive all around. Then I'm going to have one of the girls come out, hold that piece back there so I can push this into place, set the screws, and then come around and clean off any excess. All right, I've got Aspen, my little helper, inside. I'm going to peel back this piece of tape so that I can get some of that marine adhesive right on the back of this guy. I'm just sliding this out just a bit, babe. I'm actually going right around the white inner piece with this adhesive. And it'll all squeeze together once we get the screws in there. Do you feel it biting on that? Yeah. Good. Let's do the next one. All right, baby, I think you can let go. Thank you. Just gonna go around and wipe off that marine adhesive, the excess off of this plate. Yeah. I don't mind a little squeeze out. That means we got good contact, right? Just in case it rains tonight with all these clouds. Let's close her up. Look at that. Cool. Okay, here we go. I've got the Renogy Smart Solar controller screen up on my phone just so we can see if it starts pulling any current when we turn it on. I want to use the remote to see if, while the switch over here is off, we can still turn it on with the remote. And then I've got the instructions here on how to switch to a lithium battery, so our Renogy knows exactly what it's drawing from, or when it's on shore power, what it's charging. So let's try it out. All right. Now the manual says that that tone will stay on for about a minute or less. And as you can see there, that was just a few seconds. The manual also says that there's the time that it takes to actually start supplying power is about a minute. And I don't see much of a current draw yet, so this guy warming up to start supplying electricity hasn't really changed much of the draw. All right, so let's go in here and let's see if we can switch to the lithium battery settings. So it says we have to hit the enter or parameter button and hold it until it gets into program mode. So let's try that. All right, then we want to go up to 5, which is battery. It's currently set on battery 1, which is gel. We want to get all the way down to battery BL, which is lithium. So let's hit, yes, we want to change that. There we are. Let's hit enter. And now we know, I think this gets us out of programming mode. Now it knows what kind of battery it's dealing with. All right. So our output is 119 volts. No input, since we're not hooked to shore power yet. So that warm-up motor, it also said it would that would go off after about a minute as well, and then kick on from time to time when it's actually producing energy. Doesn't look like anything's being drawn. So this guy's not really taking anything right now when it's just sitting here ready to draw. Let's go up to the wiring that I have set up and let's take a reading and see how much electricity it's putting out. Reading here 124. On the screen it said 119, but nonetheless, we're getting AC power. The 110 output coming up from the Renogy inverter is going to go to this cool little breaker panel. And from this panel, I can charge all the breakers below it, and then I can individually turn on or off whatever I want to use or don't want to use at that moment. So for example, the water heater, the microwave, the heater for the cabin sleep area of the van, and outlets as an example. Now, this is a really cool little panel. The only thing about it is it's really wide in the back. And so I first cut out the exact opening for the breaker with this cool little like 2.5 inch cutting blade attachment for this Black & Decker matrix drill that I have. And I was able to plunge cut all of these cuts and then finish it off with the jigsaw. And that fit in just like that, fine, but look at all that space, and I really didn't want to lose that much real estate inside where the eventual air conditioning system is going to go. So I built this box, and this box is made out of cherry. I glued the panels together, and then I drilled and installed and glued dowel rods in there so that there's no metal. And that way it will go just like this. Panel goes on here. I'll be able to screw in on the 4 sides and not run into any side screws. And it'll look nice, and there's really only this little bit that'll be sticking out, this heavy duty wiring. So we still have the Renogy remote control to contend with. And I wanted to put it here on this same panel because I thought it would be kind of clean, you know, turn the power on and then energize whatever breaker you want. Say in the middle of the night it gets cold, you want to turn on the heater. You turn this on, energize this, and turn on only the heater. You don't have to worry about anything else inside when you're trying to sleep. The only problem with putting this remote here is this is going to be the spot for the eventual output of the air conditioning unit, and I don't want to take up any more space than I have to or have the little wiring coming from the back of it. So since I don't have that to see exactly what the opening is going to be and where I could place it, I'm going to leave all this real estate, and instead I'm going to work on the panel that goes right below it, and that panel is for the microwave. And the microwave, this is where the front of it is. It only comes back to about right here, which is going to leave plenty of room for this little remote. So you can see the 4 screw holes right here. So I need to cut an exact opening for this little protruding area so that I can then take off this little cover that comes with it and then screw it in. So I'm going to set up for that, and I'll use the same little plunge cutter to cut in, finish it off with the jigsaw. Once that's done, we're going to be ready to sand everything and get it prepared for paint. And just like when I used this bare semi-transparent paint for the frame that I built for the seats, and also for the battery box and all of its components underneath, I'm going to use this to kind of whitewash this wood. So it makes a nice white finish, but you can see through to the grain, and I really like that look. And there we have it. The Paneltronics circuit breaker panel is all wired up and ready to go. It is sitting on piano hinges on the bottom and then a couple screws on top, so when I need to, I can pivot it down to gain access to the wiring in the back when we're running circuitry. Speaking of that, it's going to be our next episode. We're going to run AC wire for all the various devices we're going to power up with the Renogy Inverter, and then we're also going to be running the DC wire for all the lights and the various other things, the water pump and all that. Next episode to come, so please tune in for that. If you found this video helpful, will you please give it a thumbs up? It's really helpful to the channel. Also, please consider subscribing. I've got a lot of tool review videos already on the channel, as well as many more to come, as well as this series that I hope you're enjoying. It's free, it doesn't cost anything. You just log in and click subscribe, or if you follow me on Rumble, follow. It's really helpful to the channel. Now I'm going to leave a link to everything I talked about in this video in the description below. Click on the more, it'll open up, and there it will be. Full disclosure, that's going to be an Amazon affiliate link, so if you click on them and end up making a purchase of any kind, it doesn't cost you a thing, but I do get a small reward at the end of the month. As always in this series, the last thing before we go is to run through the costs of the various things that we installed in this video so we can keep a running tabulation of what the cost of the build is, as well as keeping a running tabulation of the weight we're adding, since the Ram Promaster 2500 has a payload of approximately 4,000 pounds. So the Renogy 3000 watt inverter was $785, adding 65 pounds. The 2/0 gauge wire was $113, adding 10 pounds. The 5/16 inch lugs that are better suited for the inverter were $13. The Paneltronics circuit breaker panel is $143, adding about 3 pounds or so. And the 80/20 cage that you saw me manipulating at the beginning of the video added probably another 75 pounds. That brings us to this episode's subtotal of $1,054, adding 153 pounds. If you add in episode 1 through 6, we're getting up to a running total now of $8,650, and we jumped over the 1,000 pound mark to 1,009 pounds. Until next time, thank you for watching.